Amazing day. It's Miss Harris, and I'm thrilled that you're tuned in to see what's happening with Miss Harris. To ensure ultimate success for this lesson, we're going to go back and review some of the vocabulary terms from one of our previous lessons. Let's check them. Vocabulary review. Remember, a variable expression is a term or combination of terms separated by operators. They're also known as algebraic expressions. Also recall, like terms are expressions that contain the same variable raised to the same power. Simplifying variable expressions. Step 1. We'll identify the terms that have the same variable with matching exponents. Step 2. We'll use the commutative property to gather like terms. Be sure to keep the operator, whether it's the plus symbol, the subtraction symbol, multiplication, or division symbol that's on the left side of each term, attached with that term. Also, remember that constants are considered like terms since they have no variables. And step 3, to simplify, combine like terms by performing the operations to the left of the coefficients for each group. Number 1, 32y plus 17y. Step 1, we will identify the terms that have the same variable with matching exponents. The first term is 32y. The coefficient 32 has the variable y. The second term is plus 17y. The coefficient 17 has the variable y. Step 2 says use the commutative property to gather like terms. In this expression, we do see that both of these terms are alike, since they both have the variable y. To simplify, we will combine the like terms by performing the operation to the left of the coefficients for each group. So since both expressions have the letter y and 17, on the left side of 17, there's a plus sign. Therefore, we will add the coefficients 32 plus 17. Therefore, 32 plus 17 equals 49. Our expression will be 49y. Example 2. Negative 22n minus 15 plus 18n. Step 1. We will identify the terms that have the same variable with matching exponents. The first term is negative 22n. It will match with plus 18n since they both have the same variable n. Step 2, we will use the commutative property to gather the like terms. So negative 22n, we will move it with plus 18n. The commutative property won't change the value of any term in this expression. The minus 15, that constant, it doesn't have a match, therefore we'll just bring it down behind the matching group. Now, step 3. To simplify, we will combine like terms by performing the operation to the left of the coefficient for each group. So negative 22, we will combine it with the other coefficient plus 18. If we add negative 22 plus 18, that will leave us with negative 4n. Don't forget the n. And the minus 15, we'll just bring it down since it doesn't have a match. Therefore, our final solution equals negative 4n minus 15. We know that this is our final solution because the negative 4 has the variable n, and the minus 15 is a constant term. It doesn't have a variable. Therefore, our solution is negative 4n minus 15.
Number 3, 5e to the second power minus 6e plus 4e to the second power plus 3e. To simplify this expression, step 1, we'll identify the terms that have the same variable with matching exponents. Beginning with 5e to the second power, we'll notice that plus 4e to the second power is another term where they both have the same variable e with the matching exponent 2. The next group of like terms will be the minus 6e and plus 3e. Both of these are like terms since they both have the variable e with no exponent. Step 2, we will use the commutative property to gather the like terms. So the terms that both have the e to the second power, we'll group them together. Then we'll group the other set of terms, the ones with just the variable e. Now to step 3. To simplify, we will combine the like terms by performing the operations to the left of the coefficients for each group. Okay, so 5e to the second power plus 4e to the second power. On the left side of the 4, coefficient 4, there's a plus sign. Therefore, we will simplify by adding 5 plus 4. 5 plus 4 equals 9, and don't forget the e to the second power. Now, for the next group, we have negative 6e plus 3e. We already established they both have the variable e. Therefore, we will look at the operations on the left side of each coefficient. The 6 has a minus sign. That minus sign will be converted to a negative. We will read this as negative 6 plus 3. So the negative 6 coefficient will be added to the 3 coefficient. Therefore, negative 6 plus 3 equals negative 3. But we will write it as minus 3. And be sure to keep the e. And to make sure that our solution is correct, we have 9e to the second power minus 3e. We know that this is our final answer because the 9e to the second power, that e has the exponent 2, and the minus 3e, that e just has e by itself. Now we're done.
Number 4, 9 minus 7c plus 2. To begin, step 1, we will identify the terms that have the same variable with matching exponents. The first term is 9. 9 doesn't have a variable, therefore it is a constant. We know that we will group all constants together. So the other constant is plus 2. The other term we have is minus 7c. It doesn't have a match, therefore we'll leave it where it is. Step 2, we're going to use the commutative property to gather the like terms. So both of the constants, 9 and plus 2, we will group them together And the minus 7c, we'll just bring it down. Now we will simplify. We will combine the like terms by performing the operation to the left of the coefficients for each group. Here we just have one group. 9 plus 2, we'll add those constants to get 11. And the minus 7c, since it doesn't have a match, we'll just bring it down. Our final solution will be 11 minus 7c. To check our answer, we'll see that the first term, 11, is just a constant. And the second term, minus 7c, the minus 7 has a c on it. And we know since both of those terms are unique, we're done. Here's our solution, 11 minus 7c. All right, ladies and gentlemen, now it is your turn. Let's use the previous examples to solve these problems on your own. Here's the first problem. Simplify 59p plus 8 minus 2p minus 7. Here we go. Let's get started. All right, let's check it. You should have gotten 57p plus 1. Did you get it? Great job. Let's check our work. Now let's take a look at our next example. Simplify. 8p to the second power r to the second power minus 7p to the second power minus 4p to the second power r to the second power plus 25. I know you can do it. You ready to try it? Let's go. For this problem, your solution should have been 4p to the second power r to the second power minus 7p to the second power plus 25. Did you do it? Awesome! Now let's check your work. All right, let's do our next example. Simplify. 13w to the third power plus 4w to the second power plus negative 8 minus 7w to the third power plus 5. Take your time, but I know you can do it. Let's go. Okay, so your solution should have been 6w to the third power plus 4w to the second power minus 3. Did you get it? Spectacular job! Now let's check it. right, here's our next example. Simplify. -2/5 K plus 9 minus 1/5 K minus 15 plus 17. Take your time, but I know you got it. Let's go. Let's check our work. You should have gotten -3/5 K plus 11. Did you get it? Awesome job! Now let's check your work.
For this next problem, we're going to combine what we have just learned to problem solving. We're going to make connections with what we have just learned and see how it connects to the real world. Let's look at this example. Mrs. Harris earns $11.50 per hour baking and delivering cookies. Last week, she worked 8 hours and she also worked 8 hours the week before. Between those 2 weeks, she was charged $13 for a late delivery. Write an expression to represent how much money Mrs. Harris earned during those weeks. To solve this problem, here's what we know. We know that Ms. Harris earns $11.50 per hour. We know that last week she worked 8 hours. So to write an expression for this, we'll do $11.50 times 8. This represents how much she earned last week. The week before, Mrs. Harris worked 8 hours again. And we'll come up with another expression, $11.50 times 8. And we're adding that because that's an additional week that she worked. And we know that she was charged a $13 late delivery fee. Because she was charged, that means she had to subtract that amount away from how much she earned. So to solve this problem, we will combine like terms. The $11.50 H plus $11.50 H, that represent the 2 weeks that Ms. Harris worked. When we combine those, we'll be left with $23 H. The minus 13 is a constant. It doesn't have a match. Therefore, we'll just bring it down. We'll subtract that value from how much ever we made in those 2 weeks. That leaves us with $23 H minus $13. This expression represents how much money Mrs. Harris earned during those weeks.
What we do here is go back.